Guys, Mr. Sonnenberg here. Today what we're going to be talking about is changing momentum. Change in momentum is what we call it impulse. So basically the combination of the size of the force and then the duration of time at which that force is applied to something is called impulse. So impulses change momentum by they either increase or decrease it. So they either increase the number or decrease it. But the bigger the impulse is, the bigger the change of momentum will be. And so remember what we talked about with momentum and what momentum was an object moving forward. Was it easier to stop the momentum of a large ship, or was it easier to stop the momentum of a canoe, right? So it depends on the size of the force and the size of the object, but also it's going to have a relation to the time at which it takes for that particular object to stop. Okay, so impulse can be calculated in one way, and that is by, and if we just look down here, okay, we multiply force by time. So the amount of force by its time, and we'll talk about those a little more in detail here. So when we're measuring the impulse, okay, so when we're working with impulse, we use specific measurements. So impulse is going to be calculated as, the units are going to be kilograms of mass by, or mass over time, or divided by time, or I mean seconds. Sorry, holy cow, butchered that. Okay, whereas force is going to be measured in newtons primarily. Okay, the symbol is going to be N, and then time is going to be measured in seconds. Okay, right here. So when we use these equations, or that equation, force times time, we're going to usually measure it in newtons times seconds. Okay, and then what it'll give us, or newtons or kilograms per meter, or meters seconds squared. Per second squared. That's force, but it's going to give us this N value here, okay? And so that's what impulse will be measured in. So when we write that out in equation, you'll see why that's important. We'll go through a practice here as well. Okay, so I have a practice problem right here. So a car is hit from behind by an identical car with a force of 60,000 newtons. Okay, both cars come to a stop, okay, within 4 seconds. What impulse was experienced? Okay, so I just have a calculator here that's going to help me with the math. But anyways, basically what's going to happen is the first thing I need to do is I have to determine what I have here. Okay, so what's given, what information is given to me. Okay, so the car is hit from behind, the force, okay, so I know force is going to equal 60,000 newtons, and I always put the symbol in there so I know what we're measuring it in. And then the time, well, I know the time because it says it's 4 seconds, so it stops in 4 seconds, but I don't know the impulse. Okay, so I don't know the impulse. Okay, so now what I need to do is I need to write out my formula. Well, I know that my impulse is going to equal my force times my time. So now I'm going to plug in the values of what I know. So impulse, I don't know, it's going to equal 60, oops, sorry, that's not very good, 1,000 newtons times 4 seconds. Okay, so if you just do the math, you could probably do the math in your head for this one, 6 times 4, and then add the zeros, but the impulse is going to equal 240,000, but now I have to put the value, so it's kilograms, okay, meter squared. Okay, so that's going to give me my impulse. So the impulse that was experienced, okay, when the two identical cars came to a stop, was that 240,000 kilogram meter squared. Okay, so impulse and force. So if we talk about impulse and force, the impulse is going to, obviously, it's going to increase the larger the force that's applied. So example is if I had 500 newtons over 2 seconds, there's going to be greater impulse than if I had 50 newtons over 2 seconds. Also, another example, if I had 50 newtons for 5 seconds, would have a greater impulse than a force of 50 newtons over 2 seconds. So if I increase the force over the same duration of time, I'm going to have greater impulse. If I increase the duration of time but have the same amount of force, I'm still going to have an increase in impulse. So larger impulse can change momentum a great deal. So what does that mean though? Basically, you can change momentum by 2 ways. We can by applying a greater force. So if I want to change momentum, greater force is going to do so. And then I can change momentum by applying force for a longer period of time. So I can increase the force, or I can just have the same force, but I can apply it for a longer period of time, and that's going to change the impulse. So what if I need to change momentum quickly? Okay, well, an example of this would be, I'm going to try my drawing skills really quick, and they're not going to be good, but I'll just draw an ugly little car here. So I have a car, okay, and it's driving, looks like a boat, little antenna, okay, driving on the road, okay, right here. Then it comes to a stop sign. Oops. Okay, this is the best I can do, guys, come on. Now you're probably laughing at me right now. Stop laughing, stop it. Anyways, that's my stop sign. Looks like a lollipop, whatever. Anyways, the vehicle stops over a duration of time. Okay, so basically what we're talking about is this right here. Okay, gradual change in speed when it stops at the stop sign is going to ensure that people are safe, right? There's less force if we gradually apply it over a short or a longer period of time. So it could be the same force, and I'm going to draw another diagram, but there's more time, so there's less force, okay, or less impulse. But if I draw a vehicle that's driving, and I'll try to draw the same model of car, ugly as the first one was, that doesn't look the same. Anyways, now what happens when it is going to run into a brick wall right here? Okay, so it runs into this wall. Notice that the difference in time, okay, that it's going to be able to stop, it's going to stop almost instantly. Boom, it hits that wall and it stops. So there's an immediate change in force, and that comes from here, or immediate change in speed. So that's going to create more force. So when we change momentum quickly, we increase the force. When we change the momentum gradually, we have less force that's applied. There's still force, but there's less force that's applied. So you want to know the difference between those two. So is momentum lost though? So when we change momentum, do we lose when we stop an object, we lose momentum? So when an object slows down, the momentum appears to be lost. It causes, and so where does it go? So we want to know what happens there. So the energy of movement is changed to different other kinds of energy. So one, we have friction. Okay, so the rubbing. So I'm creating friction with my hands right now. So frictions in brakes in vehicles or other machinery, the brakes and in between the road, because there's friction as I'm driving on the road, my tires driving. There's friction every time those two surfaces touch with one another. But what that friction is going to do is it's going to cause heat. So sometimes in large crashes, what's going to happen is that there's going to be enough heat created by the friction that it could even ignite the vehicle on fire. So the energy may also be lost in crumpling metal or shattering glass. Okay, so in order to crumple that metal, it takes a lot of force, and in order to shatter glass, it takes force, and we can lose energy in these different forms. So friction can cause a loss of energy, and then energy due to crumpling, shattering glass can also be one way that we can lose energy when we appear to lose momentum. So basically, in many collisions, though, momentum is not all lost, though. So objects that collide continue to move in some direction. So if two vehicles collide, boom, they might bounce off one another and change direction. So we don't lose it all on the initial crash. We actually lose some afterwards, and they'll move in a different direction. So then the amount of momentum lost will vary, though. It depends on the conditions, right? If there's summer conditions versus winter conditions, the roads are icy and such, you might slide a little bit farther because there's less friction on the tires and the surface. or whatever the circumstances might be, okay? So, leads us to the law of conservation of momentum, okay? So, basically what this is it means that the total number of two colliding objects, okay, it stays the same after their collision, okay? So, the momentum that came in, the total momentum of the two is going to be the same. So, if they have the same force, then, and they're moving at the same momentum, they're going to collide, then they're just going to stop. So let's just picture this, okay? A vehicle from behind is going to rear end the vehicle in front, okay? So what happens to the momentum of that vehicle? So the momentum of the vehicle in the front here, okay? So we're going in the same direction. This is the rear end of the vehicle. This is the front end of the other one, okay? So the front will increase. So the momentum of the front vehicle is going to increase because it's going to be pushed forward, and it's going to see what we call a positive force. So this one's going to come, okay? They're moving at a speed, boom, increases the momentum of the vehicle as it hits the rear end. Then the momentum of the vehicle in behind that did the rear ending, okay, is going to decrease the momentum because the vehicle slows down because of the impact that occurred at the back of this vehicle. Okay, so it comes and it's going to slow down. It was traveling this fast, okay, but this one speeds up, this one slows down, and the back vehicle is going to experience what we call a negative force because its speed was stopped. So in head-on collisions though, now if I turn those vehicles around and now they're both coming at the same direction, we want to think about how does the law of conservation of momentum apply to these head-on collisions. So I want you to consider this. So there's two vehicles are traveling on a highway in opposite directions. They have the same momentum and they hit head on. What happens? Well, both objects are in motion and in the same momentum. Okay, so we're both in motion, we're both moving, and we have the same momentum. The motion is in opposite directions though. Okay, so one's coming from this direction in, this one's coming from this direction in. The forces would cancel each other out though. Okay, so their total momentum would be zero. And then therefore their velocity would be zero because there's no momentum, there's no movement. So they would stop completely, and then what you would see in this vehicle crash would be a lot of crumpling, and you'd also probably have a lot of injuries because there's a lot of force that's, or there'd be a lot, there's still movement inside the vehicle is what I'm trying to say, so a lot of people would have injuries. But think about this though, if one vehicle had greater momentum than the other, so maybe it was traveling faster, it had more momentum, it's harder to stop, that vehicle would add momentum to the smaller vehicle or the one with less momentum, and then it would cause it to move backwards. So if the two came and they both had the same momentum, boom, they just stop immediately, okay? And then everything inside, they would crumple and everything inside would fly around, right? You'd probably go and hit the steering wheel or whatever happened, right? But if one was larger and one was smaller, then they had different, this one had more momentum, maybe because it was bigger. Like if you take a look here at the vehicle, these vehicles, well, which one has more mass? Okay, well, 1,000 kilograms here, okay, to 3,000 kilograms here. More mass, it's going to create more force, okay? It's going to have greater momentum moving forward, this truck is right here. So it's going to hit the car, and what's going to happen to the car? Well, then it's going to hit, and the car is going to move backwards, and we're going to see this shift, okay? And so, because it has less mass, it's going to have, and the truck has greater mass, it's going to, in that head-on collision, the car is going to experience negative force, or the truck's going to create or feel positive force, and it's going to move the car backwards probably. No, not probably, it will. Okay. All right. So that is, that's changing momentum, guys. Hopefully this has helped. And remember, you can play, pause, rewind these screencasts, and they'll help you with your post assessments and such. Anyways, hopefully that's helpful. See you on the next screencast.